Hope all of us are doing fine. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. In our discussion today, I'm going to do a summary of the effect of heat on carbonates and hydrogen carbonates. And these are going to assist us in trying to analyze perhaps some of the processes which are going to be used in obtaining products of carbonates of or products of carbonates of group 1 elements. And these, of course, are going to be essential elements which are basically mentioned in our first discussion on sodium carbonate and perhaps potassium carbonate and other, of course, compounds which we are going to see later. Now, for us to understand how these specific schemes of reactions are going to take place in obtaining the final product of these two compounds, it's essential for us to understand the effect of heat on some of the carbonates from our general discussions on carbonates. So in this case, I'm going to just have a few reminder for us in trying to, of course, analyze this. Now, we had said that in some of our discussions on the concept of heat on compounds, we had said that the effect of heat on some of the compounds are going to be decomposing those specific compounds. And in this case, for the carbonates of group 1 or the hydrogen carbonates of group 1 elements, we're going to see that there are some of the carbonates which are not going to be easily decomposed. And these are going to constitute the carbonates of sodium carbonate, potassium carbonate, and of course, I can just mention this one for the sake of discussion, general discussion. So we're going to have ammonium carbonate as well, which is going to be not easily decomposed in this case. Now, in the scale of perhaps conducting some experiments in the laboratory, if we burn this one using the Bunsen burner, they are not going to be decomposed easily. But if you look at the concept of a hydrogen carbonate, we're going to see that the hydrogen carbonates, especially of these sodium and potassium, are going to be easily decomposed on heating in order to produce some of the products which we are going to see later. So in this case, we are going to have this sodium hydrogen carbonate and potassium hydrogen carbonate reacting or being decomposed, and they are going to produce the metal carbonate. And of course, that's going to be accompanied with water plus evolution of a gas which is going to be carbon dioxide. Now, in this particular case, then therefore, if we look at the reaction between or the decomposition of a sodium hydrogen carbonate, then therefore we're going to have this one producing sodium carbonate plus water plus carbon dioxide. Of course, it's essential for us to write these specific states. So we're going to have this one. So this one is okay. That is it. So we're going to have sodium hydrogen carbonate being decomposed to produce this specific product. In this case, we can just have a stoichiometric, of course, reaction whereby we're going to have this specific reaction. Let me check out whether the reactions are correct. Yeah, I think that one is correct. And if we have potassium hydrogen carbonate being decomposed, this is going to result in the formation of potassium carbonate, and then we're going to have water plus carbon dioxide given as such, and this is going to be a solid liquid and gas given as such. So these are some of the reactions that we're going to see being used on the scale of a laboratory, perhaps in trying to obtain some of the products which we have just listed on the board. And as I said, of course, our main interest is obtaining these essential elements, which we are going to, of course, be seeing as the products of the carbonates of group 1 elements. Now, in this particular case, then therefore, this is going to assist us contrast between the carbonates and the hydrogen carbonates in terms of their reaction whenever they are going to be exposed to heat, as I said. Now, other compounds which are going to be decomposed on strong heating are going to produce different products. For instance, if we try to compare other carbonates of metals like copper, lead, zinc, and perhaps magnesium, we can just have a general, of course, example for us to understand this specific case for the product. So if we have copper carbonates being decomposed, this is going to produce copper oxide and, of course, carbon dioxide gas given as such. So this is going to be solids given as such. So this is going to be one of the general example. Now in this case, if you try to look at this, hydrogen carbonate is going to be decomposed to produce metal carbonates, water plus carbon 4 oxide. But carbonates like this one is going to be decomposed. This is of other metals apart from the sodium and the potassium, which we said are not easily decomposed. Now the carbonates of other metals are going to produce metal oxides and carbon 4 oxide, given as that specific example. Now there's a unique case for this specific case which I've said, and of course we're going to consider the concept of this specific. I mentioned the concept of ammonium carbonate, but that one of course we're going to look at it in a different video, perhaps under the Solvay process which I mentioned. Now, we can have a general statement for the reaction of these specific carbonates or hydrogen or the effect of course, heat on the hydrogen carbonates and carbonates, and that's going to form a final bit of discussion on this specific example. So, generally, we're going to have the metal carbonates, which are going to give a metal oxide and carbon 4 oxide, and that's of course I'm going just to say that all metals or all metal carbonates are decomposed by heat to produce metal oxides, except sodium carbonate and potassium carbonate, given as such. And of course, I've mentioned the concept of ammonium carbonates, which we are going to look at it in a different, of course, video. And of course, we're going to see that for the hydrogen carbonates of sodium and potassium, they are going to be stable at room temperature, but upon heating, they are going to be decomposed as per the reactions, the previous reaction, which are just given in this specific case, for example. So in this case, I'm going to request our members to check our description boxes for various links of other videos, and also like to welcome our new members and join the group and subscribe to our channel so that you can form a large community of members discussing various topics. So that is it for now, guys. Bye, God bless you. Catch us in our next video.